Hello, friends. Recently, Komplete UI was introduced in Kontakt, having been first presented with Kontakt 8. Komplete UI is a new framework for creating modern, high-resolution interfaces. This framework is designed for Kontakt library developers. It allows you to build beautiful and scalable user interfaces using the new Komplete script language. If you, like me, have no programming experience and are just starting your journey into creating Kontakt libraries, this video will be useful for you as it requires no prior knowledge or coding skills. You will be able to start building your own instruments even if you're attempting it for the very first time. I created this video tutorial because in my search for information on this topic, I encountered a complete void and found almost nothing besides the official documentation. The documentation itself lacks beginner-friendly code examples and clear explanations, so I had to figure things out almost from scratch. And it is this experience, my dear colleagues, that I want to share with you. I am just beginning to dive into the world of creating instruments with Komplete UI and Komplete script, so please don't judge me too harshly if I misspeak here and there. However, all the practical information will be reliable and verified. I will also be providing links to ready-to-use code files and PDFs with comments, so you can navigate this process without the frustration of early failures.
The documentation on the Native Instruments website, the link to which you will find in the description of this video, contains detailed instructions for the initial setup of the sampler, project file placement, and the installation of the extension for Visual Studio Code. Therefore, I will not go into the details of this process, as the primary interest lies in what is not explained in the documentation. It is precisely this that I am going to devote the most attention to. I also do not plan to cover the topic of design refinement, and will only touch upon the technical side of these matters. To get started, you will need Kontakt 8 and Visual Studio Code. If these two programs are already installed, you can safely begin. I want to caution you right away against using AI agents within Visual Studio Code, as they are not trained in Komplete script, and the process of creating even the simplest code turns into a real battle with the agent, where the roles of teacher and student are reversed, forcing you to spend time training the agent instead of figuring out the code on your own, using the documentation and your own ingenuity. This applies only to free agents operating within Visual Studio Code, but not to all AI-based systems in general. Some systems can assist you in studying the available documentation, but no matter how powerful they are, do not expect them to be able to produce ready-made code for you. With that, I will conclude the introduction and proceed to create the project. To avoid any gaps in this lesson, I'll provide a brief explanation of the very first steps to get started. This information is available in the documentation, and you can refer to it if anything is unclear. The first thing you will need to do is download and install the extension for Visual Studio Code. This extension will help you understand and create code by highlighting the Komplete script syntax. You can insert suggested code by pressing the Tab key. You also need to download the Kontakt Controls package. This is a package of pre-configured UI elements that you can use without spending time creating them from scratch. I should mention that the interface design is not limited to this package, and you will be able to create your own custom element libraries to your liking. Open Kontakt and go to the Settings. In the Developer tab, find and enable Developer Mode. In the View menu, select Classic View in Kontakt. To create an instrument, go to the File menu and then click New Instrument. After creating the instrument, save it by selecting File, then Save As. Create a folder and save the new instrument inside it. Next, you need to create a resource container. To do this, Open the instrument editor by clicking the wrench icon in the upper left corner of the instrument's header and then select Instrument Options. In the Instrument tab, click the Create button next to Resource Container. Navigate to the folder where you saved your instrument and save it there. After clicking the Save button, a dialog box will appear asking to create the resource folder structure. Click Yes. Now you need to create a file named main.kscript in the Resources Complete Scripts folder. You can do this by creating a regular text file named main and changing its extension to .kscript, or by creating it from within Visual Studio Code after opening the Complete Scripts folder in the program. After this, you need to connect the created main.kscript module to the instrument via its settings. Add the simplest code to main.kscript to check if you have done everything correctly. If everything is right, you will see the standard phrase, "Hello World." Komplete UI is a layer built on top of the legacy KSP, so all UI elements created in Komplete UI are connected to the KSP, where all the core logic of the instrument is created.
Now let's create a nice background for the interface and set the dimensions for the instrument. If you download the file provided via the link, you will find not only the full text version of the lesson, samples, detailed instructions, and scripts, but also several images for experimentation. Copy all the images from the Images folder to the Resources folder of the created instrument. Resources, Pictures. In the Lessons folder, you will find the corresponding code. Copy this code into the instrument's main.kscript file, opened in Visual Studio Code, or write it yourself. You will see that a strip has appeared in the interface displaying the added background. Let's assign a more suitable size to the instrument. For example, 900 by 350 pixels. This is done in the instrument settings under the height and width parameters. Now, for the instrument's header to have the same color as the rest of the interface, add the header.png file in the instrument settings. Save the instrument via the Kontakt menu. Now let's look at the code in the main.kscript file. The first line of code imports all elements of the Kontakt interface. This is not always ideal. To avoid conflicts, it's better to import only the elements that will be used. This saves memory. However, at the initial learning stage, it's better to import everything. Errors often occur, and the code stops working because some elements are imported by default. Then, when trying to import them again, an error can occur, the reason for which can be difficult to find. If your code suddenly stops working, look for the reason in the import of elements first. Sometimes everything looks absolutely correct, but for some unknown reason, it doesn't work. Importing individual elements is done by specifying their names in parentheses, but I recommend importing everything. In the next line of code, we declare a new custom component that will serve as the main blueprint or container for our main screen. Components are the fundamental building blocks of the interface. Inside our main screen, a standard image component is created. As the first argument, we specify the path to our image. The property resizable:"true" sets that this component can change its size. In the final mandatory step, we export an instance of our main component, main screen, under the name main. Pay attention to how the path to the image file is specified. Instead of the Pictures folder, you can create your own folder next to it and replace its name in the code.
Now we will create a simple slider using the standard Kontakt controls library.
which you need to download from the official Native Instruments website. Unzip the archive and copy the Kontakt controls library to the Complete Scripts folder. Next, take the main text file from the lesson's attached archive. It's located in the directory corresponding to the lesson, and place it in your instrument's Resources Scripts folder. This file is responsible for connecting our interface to the slider logic created in the legacy KSP code. Remember, all instrument logic is created in KSP under the hood, while its design is handled in Komplete UI. Connect this file in the Instrument Settings under the Script Editor tab. Don't forget to press Apply. Copy the code from my example file and paste it into main.kscript, opened in Visual Studio Code. Now check the result in Kontakt. You should see a slider. Now let's look at the code structure. In the first line, we import all components from Komplete UI. In the second line, we import the entire Komplete Scripts library. Next, we created two components. The first adds a background image for the interface, and the second creates a slider, which is taken from the standard Komplete Scripts library. Finally, we export, or display, these two components using the ZStack component. It arranges all the elements added to it like a stack of paper, one on top of the other. Therefore, the order of the child components within the ZStack is important. ZStack is a standard component that is imported along with all other Komplete UI elements in the first line of our code. There are many such elements, so when you create your own components, be sure to give them unique names to avoid conflicts with the standard ones. The code I've provided is not the only way to implement what was shown in the lesson. There are other methods, but I'm trying to show you the most logical approach so that beginners can more easily understand the principles of component hierarchy, which are the foundation of creating interfaces in the new Kontakt.
Now, let's add an interactive button. Copy the code from the corresponding lesson folder into our working file, which is open in Visual Studio Code. I will briefly explain the important parts of this code, and a detailed explanation will be added to the lesson folder. Notice how the code has changed the tool's interface. A button, shifted upwards with a label, has appeared. Click on it and you will see that it changes color. Now study the code for this button. You will notice that the button component itself does not contain parameters for its positioning. These parameters, such as offset, are set in the component responsible for export. That is where the ZStack is located, the component responsible for laying out the interface elements. The offset parameter is added to it via the width modifier. This modifier is used very frequently and can contain many different parameters. I have shown you the simplest version of a button, but its design can be much more complex. Such a button can be reused in different parts of the interface. To do this, you can move it into a separate file and import it from there, just like any other components. Furthermore, you can create entire libraries of your own components to use when building other tools. I will talk about this later. If you need to use a custom button design based on a ready-made image created in PNG format, you can use the Alpha channel to add transparency. To demonstrate how to work with images, I have included several raster button images in the lesson archive. Place all the images in the Tools Pictures folder. You can create your own folder and change the import path to the new one. Also, copy the ready-made code from the lesson folder and add it to the main.kscript file, replacing the code from the previous lesson in Visual Studio Code. See what has happened to the tool's interface. Another button has appeared consisting of two images that switch between each other in response to a click. This new button, like the first one, parametric, is positioned within the export component using the offset parameter. The button size depends on the parameters of the frame component, and in this code is not tied to the pixel dimensions of the image. Therefore, when creating your button design, you don't necessarily have to adjust it to any specific standards. You'll find the description of the code for this button in the lesson's PDF file.
Now we will examine the principle of organizing code into modules and importing ready-made components into the main module. By splitting code into modules, we make it less bulky, more logical, and easier to understand. Furthermore, these modules can be reused in the future when creating other tools. We have already imported a slider from the standard control controls library. We can also create our own custom component sets. In this lesson, I will use a simple method for creating modules without setting up a separate library in its own folder. Therefore, all the created module files must be located in the same directory as the main.kscript file. This same modular principle can be used when creating interfaces with multiple windows for settings and effect controls. This lesson specifically demonstrates an interface with two independent windows. These windows contain their own active elements. Switching between them is handled in the main module, which doesn't contain any design elements itself, only a single button to toggle the external modules. Copy the three module files into the project's main folder, Resources Complete Scripts. Open them in Visual Studio Code. You will see that the main.kscript file doesn't even have a background. At the beginning of the code, besides the usual imports, we import components from other files. Each of them has its own background and unique element design. Take a look at the last module with the slider code. The slider component is imported and declared there, and at the end it is exported within a combined component alongside the background and text. We could have created separate components for the background and the text at the top of the code next to the slider component and added their names to the exporting final component, just like we added the slider component. You can see this principle in another module which has a more complex code structure where several components are created and their names are then added to a common component for export. This hierarchical component structure is the foundation for building interfaces of any complexity. The lesson files include a detailed code description for each module. Each lesson comes with a PDF text description and the full text transcript of this video lesson. I will also include this final project, which we will end the lesson with, in the Lesson Materials archive. If you find this topic interesting, please give the video a like to help promote it and so I can gauge whether I should make a follow-up. All the best and creative success to you, friends.